Hi everyone, family, back here on the Pet CT. We got open. I'll show you some things. So if you have a son or daughter interested to go into engineering, they like electromechanical engineering. Let's talk about it. So when you get a CT scan, this is the CT side. This is a tube. This is what produces the X-rays. It goes through this device right here called a collimator, which helps filter out how much radiation is pushed out. All right. Now on this side, this is what receives the X-ray. This is your DMS. All right. Right here, the black strip. That's what receives the X-rays as it spins around. Now this right here is a counterweight because they designed this to be balanced. On some systems, this will be replaced with what's called a UHR, or high definition receiver. It's like a screen that comes out to help the images be crisper, cleaner. This right here is the XGR, X-ray generator rotating. Now I'm using Siemens terms. With different CTs, they use different terms, but this is what Siemens calls this. This is what tells the tube to produce X-rays. Now, I'll rotate this a little bit. Right here, this is the oil cooler because this does get hot. This is the high voltage tank. This is what gives the X-ray the juice to produce X-rays. Your high voltage tank. It's a big boy, a lot of power going through that. You see as we rotate, and always remember you want to rotate clockwise from the front, counterclockwise from the back. This right here is your XDC. I forgot what the acronym stands for this one because we don't replace it that often. But this is called the UMAR, Universal Master Rotating. This communicates with the UMass, which I'll show you in a second. And it basically communicates with every component inside of here to make sure everything that is happy. This is your power distribution rotating right here. As you can tell, power distribution gives power tilting. UMAR, XCC, other components, because this breaks down the powers. The main voltage coming in 24 volts, coming out 24, 5, whatever you need, like the little ancillary stuff. All right, your DMS is covered by these two very heavy metal plates to help balance. Inside are a lot of sensitive components. It has your modules. This is your detector module assembly, like the whole thing, system, detector module system. Inside of here are individual modules that capture the image, and they all have an angle, degree of angle that they are inside of here to capture the image, the X-rays as it comes through. Once again, I'll show you the XGR. Let's go to the right side. On the right side, we have our brake resistor, which should be around 80 ohms, and this is the SCR. This servo is what rotates the gantry. It sends electrical current through it, uses the magnets inside the system to turn the system. Then what it does, it switches and it goes through here as a resistor to slow the system down. This is the UMass. This right here is the central brain. This makes everything communicate. Everything that has communication goes in and out of here. So you have your RJ45 jacks. You have your come on, I know this, optical in. You also have your serial ports up here as well, and other regular connectors. It's a lot of information that goes through here, and it makes sure everything talks. This is your power distribution stationary. So believe it or not, through here is roughly 400 volts of current coming through here. It gets broken down through here. You see right here, you can see the voltages coming out here is 5 volts, 24 volts, and this breaks it all down and sends it where it needs to go. This is your cooling unit. You can have one of two. You can have a water-cooled unit. House water's coming through here. It goes to a radiator. It pulls air out, through the system, pushes it, and it comes back around. It's a cyclical cooling setup. Or you can have air-cooled. If it's air-cooled, it won't have, this will be capped off. And on the front of it, there's a slot for air filters. Mind you, if you are a nurse or anything like that, and you work in the ER, and they want to sell you an air-cooled system, you work in a major hospital, send them packing. It has to be water-cooled. If you want the most efficiency, water-cooled systems only in the ER. All right, this is called a gym. So this is the pet side of this setup, the Biograph mCT. The gym is basically the UMass for the pet. You have all these connections lit up. That's all the cameras that are inside the pet that read the radiation coming off the patient. Because with PET and nuke med, you inject radiation into the patient. It gets to the body. You put the patient underneath those cameras. Those cameras read the radiation coming off, and it's circular from all different directions, and it makes an image in the system so the doctor can see what body parts are affected, and what could possibly have cancer, or be cancerous, or is benign, etc., etc. And so what we're going to do is, because we got to set up on the rails, you don't want to just pull back. You have a way to lock it on both sides. You have it unlocked. We're going to slowly but surely pull this back. My slope behind. Hold on. I'm going to lift the other side. This side has to be lifted up. So we're going to take these off. You see? I got this moved. And remember I told you? Here it comes up and over, back down and around. And this is also the water comes in. It also cools the pet side of this. So I got to do this with two hands, and then I'll show you what it looks like. All right, now we can pull this back. Now this is more difficult to work on than standard CT because you have to have the rails. You got to take some of the panels off just to get the slide back, so you can get in here and work on this system. All right, see, slide back pretty good. I did not take out this piece right here, which I'm gonna tell you what it is. This right here is the funnel inside the system. This part right here is where it scans through for the CT. This is your plexiglass. You might hear somebody say Mylar. Either way, this is what it scans through. And one thing we'll note is this major seam. Look at that. Oh, that major seam needs to be at a 45-degree angle, whether it's to the bottom right, top right, bottom left, or top right, left. It needs to be at a 45-degree angle to stay out of the field of view when it's scanning. All right, so here is the rear of the CT. This right here is something you need to be very concerned about if you're working on the system. This is your slip ring. This is where, this right here, which is the bus block, this is where all the power goes in and out. The major power. We're talking about 430 volts AC across most of these rings except for the neutral and ground. So these first three should be about 430 volts AC, which if you got your fingers crossed, both of them, which you shouldn't be touching the slip ring at all with your hands or even with gloves, you goodbye. All right, that's why we get paid what we get paid, because there's a lot of danger. This is a CPT system, or contactless power transmission, which is this ring right here. There's power literally going through in between these two to help power the system. Other systems have a brush block that has carbon brushes that have to be replaced. This is not. We replace this roughly every 2 years, or 1.2 million spins. So this right here is where all the major power comes in. It gets broken down per component. You see this braided line, these huge braided cables and stuff like that. The power coming in, the bus block, sends power through here. You see these cables, comes from the bus block right here, inside the system. Right there is what? High voltage tank. I'm talking about high voltage. So major stuff. Always be careful. The system's off, but if I'm going to work behind here, I would have the press S1 and the PDC. And before we get over there, let's check out this right here. So this right here is the covering for the pet. If you take this off, you'll see a bunch of cameras, and I'll probably put a picture up here so you guys can see it. There are a bunch of cameras that are connected via R45 jacks in like series. and they're all connected one by one, going all the way around. And this system has its own processor to process the images. And what these do, these two combine the images together to give a better location of possible ailments in the body. So yeah, this is what we got going on now. I will get back here in a second after I show you this video because I got to do some PM stuff. But I want to show you what I do for those who are interested. So boom, that's that. Behind here, that's how you cut power to the pet if you want to turn it off. But we don't need to turn it off what we're doing. Thankfully, I haven't had any issues with the actual pet itself when working on the system. The main issues I've had has been the CT and the pet's processing unit, which we'll go over to. Unique to this system, it has a table where all the electronics are back here in what's called a backpack, and it rides on a magnetic rail. It's unique to the Biograph, which I say pet systems. Most CTs have a standard table. If it's Siemens, it's either the PHS systems or the mCT, multi-purpose table, which allows for a carbon fiber tabletop, which is this part right here. This is tabletop support. On regular CTs, you don't have any space. It's literally just one big bulky unit, and all the electronics sit inside. And the PHS is just a standard table. Do not get the Cobra style table if you love your technician. If you love your engineer, don't get that. Get the regular table. You'll love it too. So the processing unit for the pet is the Mars. All right, this used to actually be two components, two computers, but they combined into one, which I don't like. To me, it sucks. This is the networking for the systems. This is how the systems communicate to one another outside of the UMass. All right, so inside of here, in the control room, you have a ICS. That's the main control, the image control system. Here's the image reconstruction system, which is what is a separate computer they use to reconstruct the images when they're scanning. Because everything is scanned in slices. CTs are older ones used to be 1 slice, 2 slice, 4 slice, 8 slice. Now we have 64 slice CTs, 128, etc. And they're pushing the boundaries as far as how many slices of data they can get in a scan, which gives more detail of the body, or the tomography of the body, which is CT, computed tomography. All right, so this is the PDU. I don't like this setup personally at all. But the PDU is like the breaker. It's like having an external breaker system for everything. Like if I cut power here, all this loses power. So you gotta be careful when you mess around here. You don't want to actually need to cut the power right here and then mess something up because you didn't properly shut down power to all the components going forward, along with the UPSs, or uninterrupted power supplies. All right. In here, this is the PDC. I'm more familiar with this. Power distribution cabinet. A lot goes on in here. All right. You guys remember the XGS from last time that was giving me hell? K2, you were trying to get it working. And this is all this has to be here for the system to function correctly. This is your 3 phases of power coming in. This is where the 430 volts comes in initially. Series power. Do not play around. Do not play around. I was working on F1 and I forgot to turn off this UPS. And you see this metal right here? It's good on metal. I had my Allen wrench in here without having this turned off and this turned off. I turned it. I had a flash burn right here. Thankfully, it chose the path of least resistance and not my finger, because I would have lost my finger and my job, because you're not supposed to play around electricity like that. Thankfully, I didn't lose my finger or my job. All right, this is a long time ago. This is years ago when I first started on my own. Yeah, man, this is all network switches, more communication. This is another communication hub, but this is what all is needed for a CT to work. And this powers the CT and the these two can power the CT and the PET. The PDU is more so the PET's power, but the PET doesn't have any moving components. All right, everything's stationary inside of there. So, yeah, B1 family, this is what I do. This is one of the newest things I've learned, the PET side of it. I started the CT. I wouldn't say I mastered CT. I would say I'm mastering CT. And there's more to come. When I go through things and I start seeing things, I'll try to record it and make a video for you guys. So if you got somebody that's interested, like, man, that's dope. If you do CT as a tech, as a CT tech, you scan patients, and you want to switch over, cool. It's about 2 years of school, and with an associate's degree, you actually jump right into this. You don't necessarily need 4 years. And then what you have in the experience that you have, knowing that side of it, they might give you a leg up. And if you want to choose a different career path, I can put you on that too. Let me know in the comments. All right, y'all. This is what I got for you. Peace.